All right. Hi, folks. Larry Mussolino here. I wanted to go over a few topics from Module 8A and 8B. So let me start with Module 8A. First one here is write the equation of a line through two given points. And let me get an example that's a little different. Let's take a look at this one. All right. Well, if you think about what this line looks like, let me graph these points just to get a sense of what this graph looks like. -4, -6 is a point down here somewhere. And 5, -3 is a point down here somewhere. So I do have a visual picture now of what this line looks like. It looks like it's an uphill line going through these 2 points. All right, well, I'm going to use this equation, y minus y1 equals mx minus x1. This is called the point slope form of a line. And the reason I'm using this is I know a point. We actually know 2 points. And I'm going to figure out the slope in a second. So we'll know a point and we'll know the slope. First thing I'm going to do is label these as x1, y1, x2, y2. All right, let's find the slope to get started here. The slope is m. And I can use that formula that says y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's a slope formula. Let me go plug in. Our y sub 2 number is -3. So I'm going to drop in a -3 here. I'm bringing this subtraction sign with me. Now I need the y sub 1 value, which is -6. Let me go to the bottom of the fraction. I need x sub 2. That's 5. Subtract x sub 1. Our x sub 1 here is a -4. But whenever I subtract a negative number, that flips to be an addition. So this is going to be -3 plus 6 over 5 plus 4. So that looks like it's going to be 3 over 9 for the slope. But usually we simplify the fraction as much as possible. So I'm going to divide top and bottom by 3. So our slope is going to be 1 over 3. So now we know that m is 1 over 3. All right, let me go to this point slope form of the line because now I think we could plug in y minus y1. Our y1 number was -6 equals m. M is the slope. We just figured that out as 1/3. X minus x1. X1 is -4. And really, I'm done. I could leave my answer like this, except whenever you subtract a negative, it flips to be addition. So I might as well write this as y plus 6 equals 1/3 x plus 4. And they're not asking me to do anything else with this equation, so I'm going to leave it the way it is, and this would be the answer that I'm looking for. All right, so that's finding the equation between 2 points. Find the slope first, and then use this point slope form of a linear equation. All right, let's go to another topic here. It says write equations for lines parallel or perpendicular. All right, let's take a look at this one. Well, let me start out with the parallel line. One thing I know is parallel lines have the same slope. So let me find the slope of this original line. So for this given line, first thing I'm going to do is add 9x to both sides because I want to get y by itself here because I want to know the slope of this line. So I'm adding 9x to both sides. That's going to cancel out this -9x. I'm going to have -8y equals 9x plus 8. All right, well, I'm going to divide everything by -8 here because I want to get y by itself. So it looks like y equals, now 9 over -8, I could write it as -9 over 8 by putting the negative sign up on top. I don't have to do it, but I think that's the best way to write it. And back here, 8 divided by -8 is a -1. Now I compare this to y equal mx plus b. Well, I could see the slope of the given line is -9 over 8. So let me write that. The slope of the given line here is m equals -9 over 8. All right, let's go and write the equation of the line parallel to that line. I'm going to work with y minus y1 equals mx minus x1. I'm going to label this point they gave us as y1, x1, y1. Now, what slope should I use? Well, the parallel line will have the same slope as the given line. So I'm going to use negative 9 over 8 again. So it's going to be y minus a negative 5 equals, for this slope, I'm using the same slope, negative 9 over 8, x minus 1. Again, whenever you subtract a negative number, that flips to be an addition. So I'm going to write as y plus 5 equals negative 9 over 8, x minus 1. I could leave my answer like that. So this is the line parallel to the given line through the point. All right, let's do the perpendicular line. Well, for a perpendicular line, what I have to remember is the slope is the negative reciprocal of the slope of the given line. Negative means I got to change the sign. So this given slope was negative. I got to change it to be positive. Reciprocal means flip the fraction upside down. So 9 over 8 is going to flip to be 8 over 9. So this is the slope of the perpendicular line. All right, let me go and write the equation then. Y minus y1 equals mx minus x1. This is going to be y subtract negative 5 equals 8 over 9 slope, x minus 1. And I'm really done, except I'm just going to change the subtraction of negative 5 to y plus 5. So here is my answer for the perpendicular line. All right, so I had to make use of the fact that for parallel lines, the slopes are the same. For perpendicular line, the slopes are negative reciprocals of each other. That means the slopes have to be different signs, and the slopes have to be flipped fractions as compared to one another. All right, let's go look at module 8b. Now, 8b is a little different because 8b is going to ask you to find systems of linear equations. And so let's go take a look here. Let's start out with this one about interpreting the graphs of two functions. All right. So it looks like they're showing me here two lines, a blue line and a red line. And it says Amy can choose either plan A or plan B for her long distance charges. And so it looks like they're showing me cost versus minutes used. All right. Well, let's take a look here at the first question. It says if Amy makes 150 minutes of long distance calls, which plan costs less? Well, let's find the cost to use plan A for 150 minutes. The way I can answer that is go to 150 minutes, which would be right here. This is 150. And I'm going to go up to plan A. Oops, right here. I'm going to go to plan A. And it looks like it's going to cost me $12. So cost for plan A, $12. Let me do the same thing for plan B. I'm going to go to 150 minutes, which is right here. But now I'm going up to plan B, which is this point right here. Well, I could see this is going to cost me $24. So the cost for plan B is $24. Which plan costs less? Well, obviously plan A. How much less? Well, I'm comparing $24 and $12. Plan A is $12 less. To get that, I would take 24, subtract 12, and get the answer 12. Okay, so I can use this graph to answer these questions. Let's see what part B is about. And it says, for what number of minutes do the two plans cost the same? All right. Well, if I go to the graph again, where the cost is the same will be where the two graphs intersect each other. So right here at this point, both plans cost $24. How many minutes is that? It looks like it's going to be 300 minutes. So the answer to part B is 300 minutes. The plans will have the same cost, namely $24. All right. So notice what we did here. We found where the two lines intersected each other. And it turns out that's going to be useful when we go to do graphing. Let's go here, graphing a system. All right. What we're going to end up doing here, let me get another example here to get a better, let's take a look at this one. What they're going to ask us to do here is graph each equation and see where the lines intersect each other. So to find the solution, when you have two equations like this, we call this a system of equations. That means you have more than one equation. We have two equations. Graph each line. Look for the intersection of where the two lines cross one another. Let me give you a quick example. Let's have a line, one line going like that, and another line going like this. And they intersect right here at this point. Let's say this point happens to be 7, 5. So this point is 7, 5. That's the solution. The solution here is 7, 5. Now, one strange thing could happen. What if I'm graphing and these two lines end up being parallel lines? Well, parallel lines will never intersect. If this happens, your answer is no solution. So if you graph the two lines and they never intersect, you're going to use the answer no solution. One other scenario, what if you graph the line and the two lines happen to sit on top of one another? Let me make one line green, one line red. I'm trying to draw these. Imagine they're like sitting right on top of each other. If that happens, there's going to be infinitely many solutions. So these are the three outcomes. What can happen? The lines could either intersect at one point, or be parallel lines, or be overlapping lines. Well, let's graph these and see what happens. For this first equation, I'm going to compare this to y equal mx plus b. If I do that, I'm seeing the slope is negative 1/3 and the y-intercept is 2. All right, I'm going to go put a point at the y-intercept 2. Let me look at the slope. Well, the slope is telling me go down 1 and go over to the right 3. Remember, the top number is the vertical change. The bottom number is the horizontal change. So I'm going to go down 1 and over 3. I'm going to put another dot right there. This is the first line, the graph of the first line. All right, let's go to the second line. Now for the second line, I'm going to add 2x to both sides because I want to get this into y equal mx plus b form. So y is 2x subtract 5. Compare this to y equal mx plus b. The slope is 2. I'm going to write as 2 over 1. The y-intercept is negative 5. All right, let me scroll down a little bit here. So I'm going to scroll down a little bit. I'm going to regraph these using the ALEKS graphing tool. In fact, let me do that. I'm going to graph using the ALEKS graphing tool. And let me get rid of this for a second. All right, let me go back to the first equation, which was y equal negative 1/3 x plus 2. So I'm using the line tool here. I'm going to go to y-intercept 2. The slope is negative 1 over 3. That tells me to go down 1, over to the right 3, click. All right, there's the first equation. Let me go to the second equation. So I'm clicking this line tool again. The slope now is negative 5. The y-intercept was negative 5. Our slope is 2 over 1. That means go up 2 over 1. Click my mouse. Well, I can see these two lines are intersecting in one location right here. Let me circle it so you can see it. Here is the intersection point. And I'm noticing that's 3 comma 1. So that point where the two lines intersect, 3 comma 1. So that's my answer. There's one solution here, namely 3 comma 1. So again, if the graphs intersect at one point, like our example did, that's the one solution. But you might get a scenario where the two lines are parallel, never intersecting. When that happens, your answer is no solution. The third possibility, what can happen is the two lines could overlap each other, sit right on top of each other. If that happens, your answer is infinitely many solutions. All right, let's go here. And by the way, when we get into module 9A, we're going to be doing more of solving systems of equations. So here in module 8B, this is kind of an introduction. All right, let's go take a look here. And on this one, they're going to ask me, is an XY pair, let me call this X comma Y, is it a solution to this system of equations? Well, here's what we're going to do on this one. Take the given XY point, substitute into equation number 1. Check if the XY point is a solution. Then, and let me label this. Here's equation 1. Here's equation 2. Do the same thing with equation 2. You're going to substitute the XY into equation 2. Check if it's a solution. The given XY point is a solution only. The given XY point is a solution to the system only if the XY point was a solution to both equation 1 and 2. Got to be both equation 1 and 2. It's not enough for the XY point to be a solution to just equation 1. No, that's not good enough. It's got to be a solution to both equations. All right, let's do it. Let's check this solution here. Let's go to equation 1. Equation 1 is 4x plus 2y equal 18. Let me plug in the x and y values and see what happens. Our x value here is -5, so 4 times -5. Our y value is 19, so 2 times 19. Does that equal 18? We got to check this out. 4 times -5 is -20. 2 times 19 is what, 38? Does that equal 18? Yes, it does. I think it does equal 18. So yes, it's a solution to equation 1, but we can't stop. We have to go and check equation number 2. Y equal -2x plus 9. All right, the y value is 19. The x value is -5. Let's see here, -2 times -5, that's +10. So on the right-hand side, we have 19. Yes, 19 equals 19. So notice this solution, this -5 comma 19 was a solution to both equation 1 and equation 2. That means, yes, it's a solution to the whole system. Now, what might happen is the XY pair they give you is a solution to equation 1, but not when you plug it into equation 2. Then your answer is no, it's not a solution to the system. So again, the XY pair they give you has to work in both equations in order to be considered a solution to the overall system of equations. Okay. Let's do one more. Should we do part B? Let's do part B. Part B. All right, that part B is giving us 6 comma 0. So that's the x, that's the y. Let's go to equation 1. 4x plus 2y equals 18. X is 6, y is 0. 4 times 6 is 24. 2 times 0 is 0. 24 plus 0 here on the left side, that's 24. But 24 is not equal to 18. So this is not a solution to equation number 1. I'm not going to even bother checking it in equation 2, because if it's not a solution in equation 1, it's not going to be a solution in both. That means not a solution to the overall system. All right, let's see. I think there was one more topic here. Here's one. It says, for each system classified as consistent, dependent, consistent, independent, or inconsistent. All right, well, here's what we got to recognize on this one. When you have consistent independent, that means the lines intersect at one point. Inconsistent means parallel lines. Consistent dependent means overlapping lines. So let me look at each graph and see whether they intersect at one point, or they overlap, or they're parallel. And they label the two lines here as L1, L2. So they actually did the graphing for you. I know they're giving you the equations for line 1 and line 2, but they went and graphed it for you, which is nice. Well, I'm noticing here for this leftmost system, they intersect at one point. That means my answer is going to be consistent independent for this one. Let me go to the middle graph. Well, I'm noticing these are parallel lines. That means there's no solution. Well, if there's no solution, we say the system is inconsistent. All right, let's do one more over here on the right side here. This is a little tricky, but these are overlapping lines. The way I know that is they're showing it as L1 and L2 applying to the same line. So these are overlapping lines. This would imply infinitely many solutions. And when that happens, we call that consistent dependent. Okay, so they're going to give you the graphs. If the graphs intersect at one point, we call it consistent independent. If the lines overlap, we call it consistent dependent. If the lines are parallel, we call it inconsistent. All right, I think those are the 4 topics from Module 8B. I think we did all of these, so I hope this is helpful as you're working in Module 8. Please let me know if you have any questions.